Section 4.3, exponential equations and functions. So we're going to be learning about how to solve exponential equations. We've already done a little bit of that in this chapter. So you'll see some of the same things we've learned before. And then we're going to learn how to find x and y intercepts and graph the functions and solve applications. 2 and 3 I'm not going to worry quite so much about. Number 1, definitely we'll work on that, do your best. Number 4 is probably the most important objective here. An exponential equation is an equation, here I'm just going to type since I'm right at a keyboard, that makes sense, right? See if I can get this to work for me. An equation that has a variable in the exponent. All right, just make that a better size, maybe change the color. I'm sure some of you might be writing, so I'm just giving you some time since I cheated with my keyboard. Makes it easier to read though. An exponential equation is an equation that has a variable in the exponent. That's what we've been learning about in this chapter. Okay, so solving exponential equations. So the first thing we're going to do is rewrite the equation in the form, let me get my pen, either with one exponential equaling the other. Oh, my notes have a different variable. I don't suppose it matters, but I might confuse myself if I don't stick with it. Let's say our base to the m power equals a different base to the nth power. Or you might actually have one side of your equation that has no exponent at all. So you could have exponents on both sides, or you might just have exponents on one side. So this is exponents on both sides. This is an exponent on one side. The methods we're learning will work for either. If both sides are exponentials, so like our first option here, and the bases are the same, so this is base b to the mth power, and this, it would also be the exact same base to maybe a different power, we are going to use a method we already saw earlier in this chapter. We're going to use what's called the one-to-one method, or property, one-to-one property. All we have to do if the bases are the same is we set the exponents equal to each other. We actually ignore the bases at that point. So the bases are the same, we set the exponents equal to each other, and then we solve. So like I said, we saw that in, I think, section 4.1. Let me go ahead and think of a quick example. Like if we have 2 to the x power equals 8 to the, I don't know, 8 to the 4th. Then we could rewrite that as 2 to the x power equals 2 to the 3rd times 4, because 8 is 2 to the 3rd, but it already has a 4th power, so we would need to multiply those together. So then, now that we have exactly the same bases, we ignore the bases. It's like they just disappear, sort of. It's not that they've disappeared, it's just we're creating a new equation with the exponents that we know is true. So then we would know the exponent, or the x value, so the exponent on the 2 would be 12. So like I said, we talked about that in section 4.1. Okay. If the bases are not the same when both sides are exponential, so that's like the first type of problem we saw, so like b to the m equals a to the n, then we're going to take the log of each side We usually want to use base 10 or base E. Then after we take the log of each side, we'll go to step 6, where we simplify and solve. Okay. If only one side has an exponential, and if the exponential is equal to a negative constant, then there's no solution. For example, if, let's say 2 to the x power equals negative, negative whatever. Let's just do something that will actually work, like a negative 16. If it had been a positive 16, then we would know that x equals 4, because 2 to the 4th power would be 16. But there is nothing that we can use as an exponent that will take a positive 2 and turn it into a negative 16. So this is not possible. Okay, if only one side has an exponential, if the exponential is equal to a positive constant, then we do the same thing we just did, which was take the log of both sides. So take log of each side. And then we're going to go to step 6. Alrighty. So, if, for example, if we have something like 2 to the x equals, let's do something weird like 13, then we would do log 2 to the x equals the log of 13. And we would move the x to the front. We would divide by the log of 2 and solve for x that way. Okay, for steps 3 or 5, use the exponent property of logarithms and then solve. So in each of these steps, when I've said simplify and solve, that means we're using that power property to change our exponent, constant exponent, to a coefficient instead. So the exponent property is move the exponent in front of the log as a coefficient, then divide. To get the variable by itself. I'm writing more than I intended to. I know some of you are really struggling and I want to give you as many details as I can. Okay, let me go ahead and stop those instructions. This video is getting too long, and then I'll go through example 1 with you.